All right, let's go over this then. So let's go over how DHCP works. Basically, here we are talking about how a particular device that is just booting up and connecting to a router or to the internet, how does it actually gain its IP address, right? That is the protocol that will basically be reviewing here. It's very fun, it's very interesting. So let's go over it. So the moment the device actually boots up and it connects to the router, what happens is that it immediately sends a DHCP discover message which contains the following sort of details, right? So I think one of the most important things that I want to point out like right away over here is the transaction ID, right? So I was wondering about this and I want to point this out, right? So if you actually don't have any transaction ID, or let me keep that for later on because it'll be a nice little point to bring up. I for now just remember that transaction ID is one of the things that is sort of kept there. It is kind of arbitrary, just meant for tracking. Okay, not that important, but yes, it is very important for tracking initially, right? We'll come over all of these things later. Then you have source port, destination port, and of course remember that routing tables, this DHCP, DNS, all that kind of stuff. Of course it uses UDP, right? UDP protocol is a cute little protocol, does not have too much overhead. A best effort protocol, it is good, may not be as secure as TCP, but who cares, UDP is good enough for these kind of things. So source port here is 68, right? So that means that the device is basically sending this message from port number 68 and it is targeting port number 67 of this particular server. Okay, very standard things. Now notice these two things here. So source address is all zeros and the destination address is all 255s, and notice how the server address, by the way, just as a interesting factoid, it is 181.141.6.170. It's very interesting. Now I want to point something out, right? I want to point this out right away. Think about it. So 192.168.1.0. Assume that this is your IP, let's say this is the start address and then 192.168.1.255. This is how valid addresses usually will sort of look like, right? That is how it is generally. So, a question that you should ask, right, if you look at this particular IP range, a very important question that you should ask is where even is 0.0.0.0. It's not in this particular range. You should also ask where is 255.255.255.255. It does not even exist here in this particular range. Where is this guy screaming then? To whom is this client yelling at? Like, no one is listening. That particular address does not even exist within this network. So what is this poor guy doing? Now the idea here is that these two addresses are so generally the way you sort of think about it is that, so this device right now does not really know what its subnet is, what its sort of network address. It does not know gateway, IP. It knows nothing. Okay, it knows absolutely nothing. So what it does is it follows this particular standard where if you are basically unknown and you sort of just have entered a particular network, you will yell at this address, right? You'll basically say that, okay, this is my, sorry, it will not yell at this address, it will say that this is my address. It will just claim to be 0000, even though it does not exist. That's completely okay. It just says that, I am 0000, because again, it does not know what its subnet is, what its IP is. It knows nothing, right? And it yells at 255.255.255.255 because that is the broadcast, multicast address, and everyone in the particular network will basically listen to it, right? And it's kind of a default thing that happens that is kind of done in within the hardware itself. It seems that these kind of messages from these kind of IPs are handled directly through hardware, right? So even though these two IP addresses may not exist within this particular block that is assigned for this particular network, that is completely fine, since the hardware kind of does in fact take care that these kind of things will happen, and it kind of reserves these addresses and says that, okay, if someone yells at this particular address, it's okay, the server is supposed to listen to that guy, DHCP server, and it is supposed to respond. That is basically how that works. Okay, so once this message is left and it reaches the server picks it up, goes, okay, that is your transaction ID, I'm noting that. It says that, look, I have a lease time of 3600. So 3600 probably seconds, hours, doesn't really matter. I think generally it is in seconds. I'm not sure. Doesn't really matter. Whatever, some unit of time, 3600 T. So it says that, okay, look at this. So your address that I'm proposing for you, right? The offer that I'm making for you is that you can lease for 3600 unit of time this particular address, 181.141.6.182 right? And it tells this guy DHCP, the client, it tells to the client that, look, I am the server and my address is 181.1416170. So it tells it that, look, you stop yelling at the wind, stop it. My address here is 181.1416170. Please contact me, and the one address that I can offer you is this one, and I'm offering it to you for 3600. Okay, and again, notice how the client is sending it from 68 port number 68 and sending it to port 67. Now since the machine, the server is now responding, the machine will now respond from port number 67 and it will respond to port number 68, right? And it makes sense, and that kind of back and forth you can notice in the DHCP request and DHCP acknowledge as well, right? And then it continues, and of course notice that now this is one very interesting thing here that you should notice, that it tells that, okay, I am the source here. It of course copies this server address, whatever its address actually is, into the source address as well, to sort of tell that, okay, I am the sort of originator of this particular message. And technically, again, this is a very nice little thing. You might think, and even I thought that, if you're already if you're already kind of offering this kind of an address to this particular guy at 0000, why are you not just copying this IP address there? Or why write 255? Why not just write 0000? Well, technically 0000 does not exist. So what it does is it just says, it just sort of screams this offer into the void of 255, 255, 255, 255. Sort of the, it sort of sends this message out to everyone. Now everyone essentially discards it, and only this client picks it up. Guess why? The simple reason why is the transaction ID. See, I told you transaction ID would come in clutch. This is the one thing that actually helps keep track of this whole transaction process that is going on, right? So they can sort of talk into the wind, they can yell anywhere they want. Eventually the thing that actually helps to trace who is talking to whom and when and in what context is sort of the transaction ID, and of course whatever the step that is going on, right? So that's what is happening. So again, destination address is 255.255.255.255. Since the client technically does not have any IP address at all, right? 0000 is not a valid IP address. It's just okay, I'm new here, please help me out. Okay, it's 0000 means that, right? So the server then sends this DHCP offer. Now the client gets that offer and goes, okay, so transaction ID that, and now it sort of affirms that, okay, thank you for offering me this lease time of 3600. I'm ready to take this client address of 181.1416182, right? And it goes, okay, so your server address is this, I understand, that is your address, and then it again the same ports again, right? And now notice how it actually is writing down its own source address, right? It writes its own source address, and then the destination address again is, it is still screaming into the wind. There is a simple reason for this. Why is it screaming into the wind when it kind of knows that this is the server address or whatever? Because again, it's related to the fact that technically it still does not have an IP yet, right? And I think there's some more technicality on why exactly this destination is still a 255. So we can look into that eventually. And then the DHCP request reaches the server. The server then simply acknowledges it, that okay, you can, fine, go ahead, you can have this particular IP address, and that's about it. It responds to it in the broadcast, and that's basically it. And I also kind of read about this, where apparently this diagram is fine, but maybe there is a certain inaccuracy or something. This one I have to kind of look into, because as it seems that when initially, let's say this device is completely fresh, completely new, never has connected into this network at all. So if it is completely new, it apparently does not directly just take this client address at all. Actually, it initially just leaves it blank, and it goes, okay, I'm ready to accept that particular IP that you're claiming, right? So I'm ready to do that. And after the acknowledgement is received, only then does it actually, take that IP up, right? So only after the DHCP acknowledgement comes in does it actually make that IP its own IP. So it doesn't plaster this IP immediately here when it's new, right? So that is what I'm sort of trying to get at. It will still have 0000. Basically, that is the point. It will still have the zeros, and that's kind of how it works when it's a completely new device. But if it's a device that already has been on the network and its lease time is about to expire, that's when this whole process is kind of done, and it is kind of streamlined as well, where instead of doing discover and offer, it immediately just sends a DHCP request, and the server immediately responds with an acknowledgement, right? So that is basically how DHCP works. It's a very nice and simple protocol. I was sort of having fun learning about this, and this let me this pointed me at NATs as well, which I kind of went into in a little bit of detail in a previous video. So yeah, that's basically it. It's a DHCP is pretty neat as well. That's basically about it. Yeah, see you then.